Hey everyone, and welcome back to our channel. Today, we're diving deep into the fascinating world of lipids. You might know them as fats, but there's so much more to them than meets the eye. Let's get started. So, what exactly are lipids? In simple terms, they're a diverse group of organic compounds that share one key characteristic: they don't mix with water. Think oil and water. They just don't blend. Instead, lipids dissolve in organic solvents like acetone or ether. Chemically, they're typically made of an alcohol and a fatty acid joined together. Common examples include fats, oils, and even waxes. Now, why are lipids so important for our bodies? First off, they are an incredible source of energy. 1 gram of fat packs about 9 calories, which is more than double the energy you get from carbohydrates or proteins. They also provide us with essential fatty acids, specifically polyunsaturated ones, that our bodies can't produce on their own. Plus, they act as a carrier for fat-soluble vitamins like A, D, E, and K, helping our bodies absorb these crucial nutrients. In our bodies, we have 2 main types of fat. There's storage fat, mostly found in our adipose tissue, which acts as an energy reserve and helps insulate us. Then there's tissue fat, which is a structural part of our cell membranes and nerve tissues. This type isn't used for energy and remains constant even during starvation. The building blocks of lipids include different kinds of alcohols. The most common one is glycerol, which forms the backbone of triglycerides, the main form of fat in our bodies. Then there's sphingosine, an amino alcohol crucial for our nerve tissues. And of course, there's cholesterol, a sterile alcohol that's vital for cell membrane fluidity and producing hormones. The other major component is fatty acids. These are long chains of carbon and hydrogen atoms with a carboxyl group at one end. Their length determines their properties. Short-chain fatty acids can dissolve in water, while long-chain ones can't. This also affects whether they're liquid or solid at room temperature. For example, unsaturated fatty acids are typically liquid oils, while long-chain saturated ones are solid fats. Speaking of saturation, let's classify these fatty acids. Saturated fatty acids have no double bonds in their chain. Think of palmitic acid and stearic acid. Unsaturated fatty acids, on the other hand, have 1 or more double bonds. If there's just one, it's a monounsaturated fatty acid, like oleic acid found in olive oil. If there are multiple double bonds, it's a polyunsaturated fatty acid, or PUFA. This group includes the famous omega-3 and omega-6 fatty acids. Some of these, like linoleic and linolenic acid, are essential, meaning we must get them from our diet. A deficiency can lead to issues like stunted growth and skin problems. Now, let's look at how we classify lipids themselves. Simple lipids are just esters of fatty acids with an alcohol. This includes neutral fats, also known as triacylglycerols, which are made of glycerol and 3 fatty acids. Waxes, like beeswax, are also simple lipids. Compound lipids are more complex. They contain additional groups. Examples include phospholipids, which make up our cell membranes, and glycolipids. Finally, derived lipids are substances that come from the breakdown of other lipids, such as steroids and free fatty acids. Lipids also have some interesting chemical properties. Hydrogenation is a process that turns liquid oils into solid fats, which is how margarine is made. Saponification is the reaction of fat with an alkali like lye to produce soap and glycerol. Yes, that's how soap is traditionally made. Finally, have you ever noticed how old oil or butter can get that unpleasant smell and taste? That's called rancidity. It's a chemical change that happens when fats are exposed to air, moisture, or bacteria. It can be caused by oxidation or hydrolysis. To prevent this, antioxidants like vitamin E are often added to fatty foods, and that's a wrap on our crash course in lipid chemistry. From providing energy to building our cells, lipids are absolutely essential for life. I hope this breakdown was helpful. If you learned something new, give this video a thumbs up, and don't forget to subscribe for more science content. Thanks for watching, and see you in the next one.